Hello friends, how are you? A very good morning to all of my brothers and sisters who are on the online, right? Okay. Uh, I just want to know, just check how many of you people are in online. Okay, right. So let me just check how many of you people are online. Okay, let me open this one also, PPT. Right. So today in this today's session, everybody will ask us, sir, what you are going to discuss or what you are going to teach. Today I am going to teach about the summary of IS 800 part 3. In this one I will cover the topics of tension members. I will cover the topics of tension members and compression members. Clauses I will talk. Okay, right. So okay, yeah. So if people are in online, please say a hi so that I will understand who are in online. Yeah, Prashanti School. Hi, hi Prashanti School. How are you? Hope you people are fine and everything is working well. Thanks, Rajanna. Right? Okay. Today, shall we start the session? Okay. Before I start the session, I just want to convey a very big hi to all of my brothers and sisters. And before I start the session, I just want to convey one more thing. There are so much of free content is already happening in this Unacademy learning app. So if you are a serious aspirant of GATE or ESE or any other competitive examination, brother, then I can definitely recommend you guys to install this Unacademy learning app. So you can install this Unacademy learning app by moving to Play Store or App Store, type this name and you can install this. After you install this Unacademy learning app, if you guys really want to follow me, right, then use this link which is given below. If you are able to use this link which is given below, then definitely you are able to follow me, right? When you are able to follow me, three advantages are there. Like whatever may be the free content that I had already done for free of cost in Unacademy learning app, that you are able to access. Second one, the future coming free lectures of mine will be notified to you. Third one, at the end of each and every free session, we will provide a notes on that particular topic in the form of PDF. That also you are going to get for free. These are the three things for free content when you are that you are going to get when you are able to follow, right? Yes. Some people will also say like, sir, okay, this is fine. Now you people tell me in this. Some people will also ask us, sir, is there any paid course? Is there, especially in Unacademy learning app? Yes, there is paid course or subscription, we call it as, is there in Unacademy learning app. After you install this Unacademy learning app, set your goal or target as this GATE and ESE. And after you set your goal or target as GATE and ESE, you in the main tab you go to plus courses or subscription. Plus courses. After you move to plus courses in main tab, move to plus courses. After you move to plus courses, there is a terminology you are able to see on the screen called as get subscription. When you press on this get subscription, there are two types of paid courses are available. One is plus course and second one is iconic course. So in plus course, generally the advantages are four. Like the first advantage is instant doubt resolution is possible when you had taken this paid course, and we are going to support you with the help of test series. That is the second advantage. And coming to the third advantage, there is no need to plan yourself. We will provide the entire plan, and all the courses provided by Unacademy are completely structured courses which will help you to crack any sort of competitive examination. And fourth one is I can say about this fourth one, like let us suppose you are absent to one of the class. In such case, you will be provided with unlimited access for the same class in the form of recorded version. So that will help you to crack any sort of competitive examination. All these are the four advantages when you had taken the plus course, right? Plus paid course. And coming to iconic, in addition to plus course advantages, there are two advantages are there. You will be separately given with a personalized mentor who will track your performance, and they will report your performance, and they will guide you. They will resolve all your doubts also. Right? That is a personal mentor. And the last one is, if you have taken this iconic course, then definitely we can say like you will be provided with a separate lecture notes, so a separate notes provided by Unacademy. So this is a sixth advantage when you had taken this iconic course. Iconic course is more up top course than this plus course. So any of these course, either plus course or iconic course, whatever may be of your interest, you can join that course, brother. But by the time you are joining these courses, plus course or iconic course, I can say you don't forget to use this code VD10. When you use this code VD10 either for plus course or for iconic courses, any of the courses, you are going to get 10% discount, brother, on all the courses in Unacademy Learning App. Any of the paid course, either plus course or iconic course, for all the things you are going to get 10% discount. When you use this code VD10, directly it will connect between you and me. It shows your trust on me. And I can say like it will directly connect between you and me, brother, right? When you use this code VD10. Some people say, sir, can it be useful for SSC JE? Yes, why not? It is definitely useful for SSC JE, brother. Definitely. Hi, Desi boy. Hi, Desi boys, Gully boys, Desi boys. Hope you are fine, brother. Right? Santosh Pal, can it be useful for SSC JE? Yes, why not? Definitely it is useful, because in SSC JE, most of the things that were asked are clauses. Those clauses only we are discussing. So simple problems that also we are discussing. It is 100% useful for you guys, brother. There is no doubt at all, Santosh Pal. Right? So let me enter. Some people will say, sir, please introduce yourself. I am Venkata Tilak Kupalapati. People call me as Venkata sir. Some people call me as Tilak sir. I completed my master's degree from University of Sheffield, England, and about to complete my doctoral degree, PhD also. My background of education is completely into structural engineering. So here also in Unacademy platform, I am going to teach only structural engineering subjects, ranging from engineering mechanics, strength of materials, structural analysis, concrete structures, steel structures, and finally to construction materials and management. And coming to this university from where I had graduated has produced 6 Nobel Prize winners, brother. So producing 6 Nobel Prize winners from a university is not a joke. You can understand the depth of research potentiality involved in that university. And moreover, this university ranking is always far better than IITs and IISc Bangalore. This is not told by me. I am completely impartial. It was advocated or supported by all the ranking agencies in global. So if you refer to any ranking agency globally, the ranking of this university is always less than 100, and it is far better than IITs and IISc Bangalore. Now, coming to my previous work experience other than teaching. Previously, I worked as a research scientist or research engineer in University of South Carolina for a funded research project. This is in USA. For the same research project, I worked as a team leader also. And in addition to this one, previously I worked as head of the Department of Civil Engineering for an engineering college called as STEM, which is in Andhra Pradesh. This is my previous work experience other than teaching. Okay, coming to my teaching experience, totally I have 12 years of teaching experience in teaching GATE and ESE and in different coaching institutes all across India. Being a structural engineer, even till today also I am working as an independent structural design consultant, brother. I personally give structural drawings to my clients. I personally give material testing reports to my clients, being a structural design consultant. This is the brief background about mine, brother. So coming to this slide, some people will also ask us, sir, can you please explain once again how we can take the paid course after you asked us to install this Unacademy Learning app. Now how we can install this one? Go to Play Store and type this name Unacademy Learning app. You are able to see a championship type of trophy in this way, and you are able to install that app. After you install that app, you are able to see a screen on the right hand side in this way. I hope you are able to see the screen on the right hand side. So in this screen, you set your goal or target, what you want to achieve, what you want to crack. That may be the GATE or ESE or maybe other competitive examinations like state PSUs or anything. Like Santosh Pal is very much interested about state PSUs. He may click that one, and after he select the goal. right? Here in this is the main tab. In the main tab, go to plus courses. After you go to plus courses, you are able to see a terminology called as get subscription. And remaining thing is same. After you press the get subscription, you will have iconic codes and you will have plus codes. You can take any of the, so you can select any of the thing, but to get 10% discount, you are bound to use this code VT10 brother. This is how you can take the paid codes. And of course you can pay the payments in terms of installments, or you can pay the same payments in terms of at a time also by using credit card or debit card, right? Some people will also ask a question like, sir, is there any other way how we can follow you, right? So how you can follow me? This is the link how you can follow me. By pressing this link, you are able to follow me. This is one way. And another way, some people will also ask us, sir, this is my main menu. After you go to this main menu, you type here, you press here free courses or free classes. Free classes or courses. After you type this free classes, or after you select this free classes or free courses in the main tab, in the search button right now you type, after that one you type this name, my name, Venkata Tilak Uppalapati. When you type my name Venkata Tilak Uppalapati, my profile will be visible to you, and my profile is visible to you. You just follow me. This is another way how you can follow me, right? When you are able to follow me, then I had already told you how you can do that thing. When you are able to follow me, I just want to convey one thing. When you had taken the subscription, when you had taken the paid subscription, the courses will be taught separately in English and Hindi, and topmost educators are going to teach directly in this paid course. And I can say every month as new courses are going to get published, as the pool of faculty are going to get increased. So I can definitely recommend you, if you are a serious aspirant of GATE or ESE or any other competitive examination, I can definitely recommend you to take this paid course, brother, right? These are the advantages of the paid course. I already talked about the advantages, like you will get direct the instant doubt resolution is the first advantage, and second advantage, you will be supported with test series support, so that you can understand your performance and you can improve your performance also. And there is no need to plan yourself. Entire complete plan is given by the Unacademy. So you strictly follow the plan, definitely you are able to crack the examination for sure. And there will be unlimited access is provided for all the classes in the form of recorded version just after the class also, right? These are the advantages when you had taken the subscription, brother. These are some of the topmost educators that we have directly, and you can see the classes will be held separately in English and also in Hindi. So you can have a look directly about the topmost educators that we have directly in the app. And coming, some people will also ask us, are at GATE and ESE, how many courses you people had launched till now, in especially in civil engineering. In civil engineering till now, we people had launched 8 courses. Out of these 8 courses, few courses are in English, few courses are in Hindi language. Few courses are long-term courses, few courses are short-term courses, right? So when you had taken subscription, you will be provided access to all the courses. So there in that particular stream, in the particular stream in which you had got subscribed in civil engineering especially, right? So now coming to the financial terms. Now if it is for 12 months course, the cost after 10% discount is 27,225, and if it is a 24 months duration subscription, the cost is 39,600 after 10% discount. To get 10% discount, you are bound to use this code BT10. I already mentioned. I can recommend this 12 months subscription course for the students who are in final year. Whereas I can recommend this 24 months duration subscription course for the students who are in third year or second year. For them, I can refer this subscription duration course. So for any of the duration course from 1 month to 24 months, I can say like definitely you are bound to use this code VT10, brother. So I just want to convey one more thing. Every day my class is happening in this Let's Crack GATE and Civil GATE and ESE Civil YouTube channel. My class is happening by 11 a.m. So you can come down to my class every day. I'm going to teach only structural subjects, and I can say like I can recommend even Kamalakar Pandey sir class. Every day his class is happening in the same YouTube channel by 9 a.m. I can even recommend Kamalakar sir Pandey's class also, right? And so as you are getting all this for free of cost, na? So if you don't want to miss even a single video, guys, then please subscribe to our Let's Crack GATE and ESE channel in the YouTube. When you subscribe, don't forget to press the bell icon. When you press the bell icon, the future coming videos of this channel will be notified to you. In such case, you will not miss even a single video. So that will be very much helpful to you to crack GATE or ESE or any other competitive examination also. And please like our videos, share our videos, please subscribe to our videos, brother, because you are getting this for free of cost. And when you refer this to your friends, definitely they will also get benefited. At least they can enjoy the free content, right now. So that means you are doing some help, definitely. So please like our videos and share our videos also. And for you guys, I already started a Telegram group. If you are able to come down to the Telegram group, you can post your doubts directly in that Telegram group. And the name of the Telegram channel is Unacademy _ Civil Engineer Tilak. If you come down to that Telegram group, use the link which is given below. And this is the link. This is Unacademy _ Civil _ Engineer _ these are all underscores are there, and it I can say if you press this link, you just type this link directly, you are able to follow me in Telegram group, definitely, right? So shall we start the session, brothers? Right? Santosh Pal, Desi Boy, Vasant Sai, Prashanti School. Shall we start the session? Okay, let me start the session, guys. Right. I hope you are able to see this question. The capacity of a single IS, okay, as a tension member connected by one leg using 6 rivets of 20 millimeter diameter. I am just asking this question. They are saying the allowable stress is, when they mention the terminology called as allowable stress, you should understand like this concept is completely based on working stress method, right? Working stress method. So in which code of practice this working stress method is emphasized? In old code of practice in IS 800 1984. So as per the old code of practice, we need to evaluate tensile strength of the member. So coming to the tensile strength of member, if it is P tensile, how we can work out the permissible tensile stress, sigma tensile, sigma allowable tensile stress, permissible tensile stress, or allowable tensile stress multiplied by net area. This is how we can work out generally. If we are this sigma allowable is already 150 megapascal. Please understand this won't come under what I can say limit state of method. This will come under working stress method, because whenever you are able to see limiting stress or allowable stress, then that means it is completely based on working stress method. Okay, that is the thing, how you need to understand whether the question is based on working stress method or limit state method. And coming to net area, here the capacity of a single angle is connected by one leg to a gusset plate. If this is a gusset plate, to this gusset plate, angle is, one second, brother, to this gusset plate, uh, angle is connected to this gusset plate with the help of 6 rivets, and all the 6 rivets are there in a single line. You can assume in this way, right? When all the rivets are there in a single in longitudinal direction, maybe I can say something like when I say all the 6 rivets are there in this way, 2 3 4 5 5 6 6, some 6 rivets are there in this way. In this case, they are expecting the tensile strength. When they are expecting the tensile strength, when this is P, this is how the critical section is, definitely. How to work out the net area as per old code of practice. So as per old code of practice, how we can work out this net area? A net. How we can write the net area? When an angle is connected, it is A1 times of K times of A2. What is this A1? A1 stands for net area of connected leg. A2 stands for gross area of outstanding leg. Outstanding leg. And if I want to work out K, the value of K when one single angle is connected, when single angle or the double angles are connected on either side of the gusset plate, then in such case the value of this K factor is 3A1 by 3A1 plus A2. See how if you are able to substitute A1, A2 properly, the problem is over. Isn't it or not, Santosh Pal? So can you work out what is this A1, brother? In this one, this 100 millimeter by 100 millimeter. So if you see, this dimension is 100 millimeter connected leg. Outstanding leg is also 100 millimeter. There is no doubt. So can I work out, guys? How I can work out this A1, brother? A1 is what is the, I want to work out net area for this connected leg. To work out the net area for this connected leg, what is the overall dimension? 100 millimeter. Out of 100, thickness by 2 is contributed to outstanding leg. So I need to write thickness is how much, brother? Thickness is 10. So 10 by 2. This is the gross width, I can say. But I need to consider net width. So how I can get the net width out of this gross width if I deduct the diameter of the hole? What is this one? This is the diameter of the hole, right? How many holes are there? One hole are there. So what is the diameter of the hole for 20 millimeter diameter rivets, brother? So for 20 millimeter diameter rivets, phi is 20 millimeter. Diameter of the hole is 20 plus 1.5, which is 21.5 is the diameter of the hole, that you already know. So minus 21.5 into 10. This is A1. This is how we can work out. And coming to A2, A2 stands for gross cross sectional area of outstanding leg. What the width is 100 na, out of 100 width, the thickness by 2 width is contributed to connected leg. So I can say minus thickness by 2, minus 10 by 2. So I want the gross area na, so there is no deduction for holes are there in this gross cross sectional area of outstanding leg. So multiplied by this, multiplied by the thickness of that outstanding leg, which is 10. If you work out A1 and A2, the value of this A1 is 735, brother, millimeter square, and the value of A2 is, brother, definitely it is 950 millimeter square. Now can you work out the value of K? If you work out the value of K, right, brother, can you work out the value of K by using this equation, which is 3A1 by 3A1 plus A2? Can you work out? So 3 times of we can work out 3 times of A1 735 by 3 times of 735 plus A2. A2 is 950. If you work out this one, the value of this K is definitely 0.7. So just try to substitute net area. Is that okay? So how we can work out this net area? Oh, sorry. How we can work out this net area, brother? Second. A net area is equal to A1. A1 is how much? 735 plus K. K is 0.7, right? And A2, how much is the value of A2 that you got? 950. Will you accept this, dear Santosh Pal? Right? When you do this one, definitely you are going to get this answer of net area. A net is definitely, it is equal to 1400 millimeter square is net area. So shall I substitute this net area as directly 1400 millimeter square? Yes, I should just substitute. Then definitely the allowable strength, definitely you are going to get as 210 into 10 cube Newton, which will be the answer is 210 kilonewton. Isn't it or not, dear? Right? Is that okay, dear Santosh Pal, Desi boys, Vasant Sai, Prashanti school? Is that okay, guys? So can you see the option is 210 kilonewton? Na? Directly we can pick option D itself is the correct option. Is that okay? Is that okay? Right? Can I move to the next slide? Santosh Pal, Desi boy, Vasant Sai, can I move to the next slide? Right, moving to the next slide, brother. Moving to the next question. Before I move to the next question, I just want to convey, can I erase all these things? Yes, if I erase this one, I just want to convey one thing here, like People had a doubt like, sir, every time generally we will work out the tensile strength. P tensile is equal to allowable stress in tensile mode multiplied by net area. How to work out net area? Always in case of all tension members as per working stress method. As per working stress method, it is A1 plus K times of A2. And how we can work out this value of K when this is a gusset plate. To this gusset plate, if only one angle is attached. If only one angle is attached on one side, then in such case the value of K is definitely we can write as 3A1 by 3A1 plus A2. This is how we can write. Now some people will say this is the K answer when one angle is connected to gusset plate. Some people say the answer is same. 3 K value is 3 like 3A1 plus 3A1 by 3A1 plus A2, where this is also the answer when two angles are connected back to back on either side of gusset plate. Even when if I take if for this case also, for these two cases, I mean for this case and for this case, you need to write the value of the K is in this way. Some people had a doubt, like some people will come and ask me, sir, let us suppose where there are two angles only, sir. If this is a gusset plate, when the two angles are connected to the gusset plate on the same side of the gusset plate, sir, in this way. In this way. So what is this one? Say when two angles are connected back to back on the same side. Here either side is the word, but here on the same side of gusset plate, right? In such case, we can say the value of this K we can write as 5A1 by 5A1 plus A2. What is A1 here? It is net area of connected leg. What is A2 stands for? Gross cross-sectional area of outstand leg. This is how the codal provisions were mentioned, brother. The same thing we had discussed. So how that single angle or double angle are connected to the gusset plate, based on which the value of this K factor to work out the net area will get changed, right? The remaining things are one and same. Shall I move to the next question, brother? Right, Santosh Pal, Desi boys, Vasant Sai, other persons who are on the online. Shall I move to the next question? Is that okay? Right? Moving to the next question. I hope you are able to see this next question. In case of single angles in tension, when there is a single angle is there in tension connected by one leg. So I hope you can say to this gusset plate a single angle is connected. Okay. The net effective area. What is the net effective area as per IS 800? As per IS 800, 1984 is the version, because as per IS 800 means this is as per old code of practice, which is based on working stress method of concepts. So both working stress method is there and limit state method is also there. So that's the reason why I coming to limit state method. I completely worked out all the limit state concepts with theory also. Maybe 2 months back or 1 month back, I completed it. So if you want to know about the limit state method in detail with reasons, you can watch that video. It's not at all a problem. here the emphasis was given mostly on working stress method, because I didn't talk much working stress method in the actual syllabus, right? So I am talking about this. So now the net effective sectional area, how we can work out the net effective sectional area, brother? Here A net is equal to, general we can write as A1 plus K times of A2. What is A1 here? A is the net cross sectional area of connected leg, and B is the net area of outstanding leg. So in such case, A plus K times of B, this is how I need to write. This is A1, this is A2 in our words. If we do in this way, how we can write this net area? A plus K. K is 3A1 by 3A1 plus A2. So I can write 3A by 3A plus B into B. So try to use this A plus, we can write this one as definitely B by this T divided by 3. If I do, this is 1 by 3 times of B by A. This is how we can write, right? So which will be the option is definitely this option. 1 by 3 is directly taken as 0.33 na, so I can write as this is 1 plus, this is 1 plus, sorry, here in this bottom this is 1 plus. So if you take A plus B by 1 plus 0.33 times of B by A, so which the option that is matching is directly option B itself is matching, right? So directly I can keep option B. Is that okay, brother? This is how, instead of A1 and A2, that A1 is taken as A, B, A1, A2 is taken as small b. So the nomenclature has got changed, but the concept is one and same. So you can pick directly the option B here. Is that okay? Right, brother? Right. Santosh Pal, Prashanti School, Vasant Sai, or any other person who are on the online, can I move to the next slide, brother? Yeah, moving to the next slide. Next question, I mean. Okay. If you see this next question, consider the following statements. So use the following statements which are below. Lug angles are used. For what lug angles are used? So why the lug angles are used? I hope first of all the main intention behind this lug angle is to accommodate more number of rivets, so that the size of the gusset plate can be reduced. So the main advantage or main interest for this lug angle is to accommodate more number of rivets or bolts, so that the size of gusset plate can be reduced due to lug angle. If I don't use lug angle within the given gusset plate, if I want to provide more bolts, in such case the length of overlap for that connection is high. In such case the size of the gusset plate required, the dimension of the gusset plate required is also high. So second, what is the major advantage why we are using this lug angle? To reduce the length of the connection, right? To reduce the length of the connection. So these are the two advantages. Let me see what are the options which are correct and not. Okay, right. If you see this first option, increases the length of the end connections of the angle section. It won't increase, man. It will reduce or decrease. This is a wrong answer. Decrease the length of the end connections of the angle section. Yes, it will reduce the. This is correct, no doubt. And coming to third statement here. Increases the length of the end connections of channel sections. For channel section or angle section, it will decrease the length of the connection, bro. So this is also a wrong. This is wrong. This is wrong. So coming to the fourth one, it will decrease the length of the end connections in case of channel section, either for channel section or angle section or for T section. For any of the stuff, it will reduce the length of the connection at the ends, right? So definitely this fourth one is correct option. So second and fourth are correct options. Which of these statements are correct? I can say second and fourth are correct now, brother. So directly I can pick option B itself is the correct option. B for poster. Is that okay? Can I move to the next question, brother? Is that okay? Can I move to the next question? Moving to the next question. I hope you are able to see next question. In a tension member, okay, in a tension member, if more than one rivet hole or off the line, if more than one rivet hole, I just want to say are not off here, maybe the terminology they had typed in a different way. So they are off the line, okay, or off the line, or off the line, the failure of the member. So in case of tension member, if there is more than one rivet hole is there, for example. So if you take a tension member, maybe I can say this is a tension member and this is how the connection, right? And if there are more than one rivet hole, like maybe the rivet holes are maybe 1 2 3, somehow like this, right? In this case the failure of the member depends on what? So you take the tensile strength P, that tensile strength is equal to, generally we can write allowable stress, maybe I can say sigma allowable into net area. Coming to this net area in case of these rivets of zigzag variation or anything. So coming to this net area, if you refer to IS 800 code of practice, either 2007 or maybe I can say 1984 code, this net area generally it is equal to, it is the minimum cross, it is the minimum area along the least, it is the critical cross sectional area. Net area is, net area, it is the critical area along which net cross sectional area is the minimum. Okay, Arjun Yadav, I used to watch all your offline videos, sir. You are the best. Thank you, brother. Thank you. Please refer the same thing to your friends so that they will also get benefited. In our brother, dear Arjun Yadav. So you had benefited something, you got benefited. So similarly, ask your friends to watch the same videos. Let them also get benefited. Okay, because we are doing this to reach for maximum number of students to get good name and fame. That's the reason why we are doing all this fun, to provide you some service and at the same time to help more students. So please inform the same thing to your friends also. Okay, okay, brother. Thank you. Now if you see, this allowable stress is constant. Now coming to this net area, brother, if you see, the net area is possible along the critical section along which the net area is always minimum. To get net area is minimum, the formula, if you refer to the code of practice, is B minus n times of diameter of the hole plus sigma psi square by 4 into gi into thickness. This is how you can take. B is the width of the plate. Okay, it depends on the width of the plate. And n stands for the number of holes which are along the critical section. N is equal to number of holes, number of rivet holes, number of rivet or maybe bolt holes, whatever that, number of holes along critical section. What is this? DH stands for diameter of rivet holes or diameter of bolt holes or diameter of holes, right? That's what I can say. PSI stands for pitch. So it depends on the, if the failure is happening along this section in this way, it depends on the pitch between these two bolts. It depends on the pitch. So PSI stands for pitch between the two bolts along the chosen of failure, right? PSI, that depends on pitch. And GI stands for gauge between the bolts which are along the line of this along this line of this possible critical section, along the line of this possible critical section, the gauge between two adjacent bolts, maybe this is first bolt, second bolt, third bolt. The gauge between first bolt and second bolt is G1. The gauge between second bolt and third bolt is gauge G2. So I here sigma stands for I is equal to 1 to number of bolts along, number of holes along the critical line of section. I may be in this particular chosen way, I can be definitely 1 2 3 na. So directly I can write I is equal to 1 2, I can write n minus 1 directly. This is how. So it is depending on pitch, it is depending on gauge, it is depending on diameter of the bolt. So it is depending on all these three. So directly I can pick the correct option is all of the above is the correct option. So I need to remove A, B, C options. I need to remove A, B, C options. I need to pick only all these are correct. Pitch depends on pitch, depends on gauge, it depends on diameter of the rivet hole. So it depends on all the three above. So directly I can pick option D for Detroit is the correct option. This is how I can pick. So is that okay, brother? Arjun Yadav or maybe Santosh Pal, brother, or any person who are on the online. Is that okay? Can I move to the next question? Is that okay? Right? Right. So I am moving to the next question, brother. This right. So if you see this next question, for double angles carrying tension placed back to back. If you take this is a gusset plate, for this gusset plate, okay, double angles are carrying tension. Maybe I can say this is how double angle. This is angle 1. So maybe angle 2. For double angles carrying tension placed back to back, and connected to either side of the gusset plate. So these are connected to either side. So this is on both the sides of the gusset plate. Okay, the sectional area of the section is equal to. So what is the net area of the section? Net area of the section is gross cross sectional area, A gross, net gross cross sectional area of the section minus area of the rivet holes, right? Minus area of holes or area of rivet holes. This is how generally we can type this net area. Net area is gross area minus deduction area of rivet holes minus area of rivet holes, means it is nothing but deduction for rivet holes. This minus of this area of the rivet holes means it is deduction for whole area, right? So this is how you can fix. Now you tell me, for the 77 question, can you work out the correct option? The net area is equal to, it is equal to gross cross sectional area minus, right? Minus is the terminology is there in option C. Gross cross sectional area minus area of the rivet hole. So I can pick option C itself is the correct option. Whereas if you take, it is gross area of the section. So gross area of the section is net area. No, this is wrong. Gross cross sectional area plus area of the rivet holes. No, not plus, it is minus. So gross cross sectional area of the section multiplied by area. No, it is not multiplied by. It is gross cross sectional area of the section minus area of the rivet hole. So directly I can pick option C itself is the correct option. Is that okay, brother? Arjun Yadav, right? Shall I move to the next question or next class? Okay, moving to the next question, right? I hope you are able to see this question, brother. A tension member, in a tension member, if the tension member is subjected to possible reversal of stresses due to wind or earthquake, the slenderness ratio of the member should not exceed. I just want to give a tabular form, brother. You need to memorize the tabular form. And I will mention the reason also why. I will give certain qualitative relationship why the slenderness ratio can be increased or decreased. So this is the condition. I can say this is the condition. This is limiting slenderness ratio, lambda limit. The condition 1 is a tension member is subjected to possible reversal of stress. What do you mean by reversal of stress? If the structure is under vibration, on the same phase tension can come, and on the same phase compression can come. There is a change in nature of stresses on the same phase. Such type of stresses are nothing but reversal of stresses, I can say. A tension member is subjected to possible reversal of stress. A tension member in which reversal of stress takes place. Reversal of stress takes place due to load other than wind and earthquake, I can say, other than wind and seismic loading. Due to load, other than, there is a clear word, other than wind load or earthquake load or seismic load. If it is, if the structure is vibrating, because of that vibration is coming into picture because of the loads, dynamic loads other than wind load or earthquake load. Maybe I can say like, what are the other loads because of which the structure may be under vibration? Because of live loads, when the moving live loads, because I can say due to, maybe example, due to moving live loads. In such case, the limiting slenderness ratio is 180. Right. This is condition 1. Now some people will say, sir, what about condition 2? The condition 2 is safe. A tension member in which reversal of stresses takes place due to load, due to wind load and earthquake load. I can say second one is reversal of stress. I can say reversal of stress due to wind load or earthquake load. When it is due to, that means here wind load and earthquake load is also acting here. In your previous case, only live load, moving live load is there, but here in the second case, in addition to moving live load, there is a chance of wind load and earthquake load is also happening. In such case, the slenderness ratio limit can be increased like 350. When more and more loads are applied, there is chance like it can buckle very easily, na? So this value of this value is, limiting value is 350 here. This is 180. And coming to the third one. So third condition, I can say, in case of tension members, right? For any other tension member other than pre-tension member, I can say, for any other tension member, I can say other than pre-tensioned members. For any member other than pre-tensioned members, I can say like its value is 400. This is how we can say. Now out of this 1, 2 and 3, I can say what is the condition that was given in the problem. Hi Vandana Simran, hope you are fine and everything is working well to you, right? Yeah. So can you say the answer? This is due to wind load or earthquake load. When it is because of wind load or earthquake load, because reversal of stress is coming into picture. In such case, the limiting slenderness ratio value is directly taken as this 350. 350 is the answer. Where this 350 is there? Directly option D. So you can pick option D for Detroit is the correct option. Isn't it, Arjun Yadav? Is that okay? Is that okay? So it depends on this tabular form. This tabular form were there directly in IS 800 2007. The same tabular form was also there in IS 800 1984. Both in old code of practice and also in new code of practice. The limiting conditions are 1 and same, right? Can I move to the next question or maybe next slide? Is that okay, dear brother? Right? Moving to the next question. Yes. So can you see this question? For a single section, use it as a tension member. The given area is assumed. So generally, this is what they are asking is, generally at the time of selection, if you work out at the time of selection and the trial section, generally we will consider the net area. How much is the net, when gross area, how much we will consider the gross area? Generally we will try to select the gross area which is 20% to 30% more than the net area required. So I can say if P is the tensile strength, of member which is equal to applied load, this is equal to this here sigma allowable into A net, I can write. The sigma allowable value, we will consider some value like 135 Newton per millimeter, or sigma allowable in tension. To be frank, exactly we can use as per old code of practice. Allowable stress, allowable tensile stress is 0.6 times of F. So this is known to us, and from this one we are able to work out net area. After we work out this net area, How we will select this section? The selection of cross-sectional area in steel tables is in such a way that gross area is 20 to 30 percentage more than the, this is A net I can say required, more than the net area A net required. This is how we will choose. If we choose the same if the net area is this much, if we choose the same value of cross sectional area, the net area will be reduced. So in such case it will be a failure. There is no doubt at all. In such case, to avoid such type of things, generally as a thumb rule, we can consider generally it is 20 to 30 percentage in excess of net area. This is the option generally we can work out. Is that okay, brother? Right, Arjun Yadav, is that okay? So the option is A. Right, this is how we will select the cross section from the steel tables when it is a rolled section. Is that okay, Arjun Yadav, brother? Yeah. Vardhana Simran says okay. What about Arjun Yadav or any other person who are on the online, like Santosh Pal, or maybe Vasant Sai or Prashanti School, or any person? Okay. So moving to the next question. So I hope you are able to see the next question. Right. So they are expecting match the following type of stuff, brother. So when they are expecting match the following type of stuff, right? So they are in axial tension. Axial, what is the, this is the question which is based on old code of practice. Old code of practice. So axial tension is given with the terminology, I can say axial tension is given with the terminology this 0.6 times of Fy, right? This I already mentioned. Bending tension is given with the terminology permissible bending tension is given with 0.66 times of Fy. Maximum shearing stress value is given by 0.4 times of Fy. This I already teach you in your previous class. If you refer, I had given these values, brother, right? And I can say, coming to bearing stress, coming to limiting or permissible bearing stress, it is 1, which is 0.75 times of Fy. This I had already given in last class or previous class as working stress method. So some people will say, like, sir, in case of limit state method, for axial tension it is Fy by 1.1. In case of bending tension it is also Fy by 1.1. in case of maximum shearing stress it is Fy by root 3 divided by 1.1. whereas bearing stress it is Fy by 1.1, like that. So there is a lot of difference between the factor of safeties in working stress method and factor of safeties in limit state method. Both are different. So as it is question, they are specially mentioned this like allowable value of stress. Whenever they use it to use this value, allowable value or limiting value, it indicates working stress method. How you can think the method is a limit state method? In limit state method, they talk this terminology of allowable stress or limiting stress as design stress. Whenever you listen to the terminology called as design stress, use limit state method. That is the difference, brother. So the correct option is B. The correct option is B for Boston is the correct option. Is that okay? Right? Can I move to Sudeep Gautam? Yes, Sudeep Gautam. Can I move to the next slide? I mean, next question. Is that okay? Sudeep Gautam. Right. Yeah. This question clause was already mentioned in your last class. This question clause was we had discussed in your last class. The tacking rivets in tension members are provided in pitch in line not exceeding. So maximum pitch of tack rivets for tension members should not be more than 1000 millimeter. For maximum pitch P max for tack rivets only, for compression members should not be more than 600 millimeter. As they are asking in tension members, na, so that's the reason why should not exceed 1000 millimeter, means should not exceed 100 centimeter. Is that okay? The correct option is D for Detroit is the correct option. Hi Dharma Railway, how are you? Sudeep Gautam has given correct option. Arjun Yadav has given correct option. It is not C. The C is the answer. It is the case. This value of C is the answer in case of compression members. In case of compression members or tack rivet. This is for tension members. They had clearly mentioned this is tension member. In case of tension member, no buckling is possible. So the limiting pitch, I can say the maximum pitch can be increased. Whereas in case of compression member, buckling is possible. Na? So I need to keep the pitch very closer than this tension member. So here lesser value for compression members, higher value for tension members for maximum pitch, right? So moving to the next question. I hope you are able to see the next question, brother. Is it or not? The failure of tension member is considered when either of the following statement is true. When I can say excessive elongation in the member. When excessive elongation will takes place, excessive elongation will takes place when gross yield, when the cross section has crossed gross yielding failure, which we people called as AG into Fy, gross cross section area into Fy by 1.1, right? So rupture strength of the critical section. So how we can work out the rupture strength? Rupture strength is equal to design rupture stress multiplied by net area. That is nothing but rupture strength. Yes. And third one is buckling of member. In case of tension members, this first one is correct, second one is correct. Buckling of member will happen in case of compression members, brother. Right. Sir, in case of open to weather, dear sir, Dharma Railway, in case of open to weather, it is 16 times of T or 200 millimeter, whichever is less. Dear Dharma, I had mentioned the same class. In case of rivets which are open to weather, it is 16 times of T, thickness of the member that we are joining, or 200 millimeter. Out of these two, whichever is lesser, we need to consider that. This I had already mentioned. That question I had already, whatever maybe that thing that you are asking, that I had already mentioned in your previous class. Okay. Now in buckling of member, buckling of member is possible in case of compression members. Na? Buckling failure is not possible in case of tension members. So this is a wrong option for tension member. And coming to the fourth one, shear block shear failure, shear block failure. This is called, we generally called as block shear failure. Right? So the first failure, second failure, and fourth failure, all these are failures in tension members. 1, 2, and 4, not 3. Third is the failure generally that will happen in case of compression member. Right? This is as per new code of practice. As per IS 800/2007, a tension member is a failure when it has got failed in excessive elongation in member, which we people called as gross yielding failure. When it is a failure in rupture at critical section, when it is a failure because of block shear failure. This block shear failure will come into picture. This can be prevented. The block shear failure can be prevented when eddy distance provided is more than minimum eddy distance. Right. Some people will also ask us about minimum eddy distance. It is 1.5 times of diameter, 1.5 times of I can say 1.5 times of I can say dia of hole, or in case of this is E minimum 1.5 times of diameter of hole when it is done by when that bolting or riveting is done by with the help of sharp bolting or sharp riveting. When it is 1.7 times of diameter of the hole, this we can do when by hand bolting or hand riveting. right? So when equidistance is provided is more than minimum equidistance, we can stop this block shear failure. This also I talked in your previous class. So I mean to say option 1, 2, 4. Option 1, 2, 4 is there for option D. Na? So directly I can say option D is the correct answer. Is that okay? Can I move to the next question, brother? Next question or maybe next clause, whatever that may be. Okay. Right. Moving to the next class or next question. I hope you are able to see this question, brother. This is P, and here in this direction also there is P. Just for equilibrium purpose. And this is P, then obviously this end will should also be P. Right. What is the effective net area of net width of the plate shown in figure for carrying tension? What is the net effective width? So if you take net area, it is net width. I can write net width multiplied by thickness. How we can write the net width if this is B minus n times of diameter of the hole plus sigma psi square by 4 into gi into thickness. That thickness is called as T. This is nothing but net width we can write, isn't it or not? So definitely, one second. Definitely we can call this one as net width. So coming to this, what is the net width? Net width, what is the net width, which is the minimum net width that is possible? Always this net area shall be considered to be minimum. Why this net area shall be considered to be minimum, along which the failure will happen if you take stress. Stress is the resisting force acting over unit area. If the stresses are crossing more than the permissible limits, when along the sectional area along which the net area is minimum, a net, when a net is minimum, along that line only the stresses developed will be more than the permissible stresses. And yes, sir. C structure channels are available in Unacademy channel. Yes, dear, it is available in this Let's Crack GATE and ESE civil YouTube channel. Na? My steel lectures are available, and some of the steel lectures are directly available in app also, in Unacademy app also for free. So you can watch them, brother. Dharma Railway. Okay, right. So when A net is minimum, this sigma will get increased. So try to choose the minimum width so that net area will be minimum. So along that line only fracture is possible. From your fundamentals of strength of materials from theories of failures, generally along which section, along which line, along which width the failure will happen, along the width or along the area along which the net area is minimum, then the developing stresses are more than permissible stresses along such path. So along that path only the cracks or fissures or whatever that may be, the failure will happen. So to get this tension failure, I should try to take a section such that for that section net width should be minimum. So net width should be minimum. How you can make the net width as minimum? So the best possible way for me is to get net width is minimum, the number of holes should be maximized. So when n is increasing, then net width decreases, and when pitches are increasing, then obviously net width increases. From this formula you go, this is minus, this is plus. Net width will get increased when pitch will get increased. Number of holes are increasing, net width will decrease. And one more thing also, the fracture will not happen in longitudinal direction. Either the fracture will happen in vertical line or maybe in inclined ways, in this way only. Fracture will not happen in horizontal line. Suppose some people will think like, sir, the fracture can happen in this horizontal line. It is not possible. In the horizontal line, if the fracture is happening from maybe first bolt or second bolt, from between first bolt to second bolt, or maybe here you can take, if the fracture is happening in this way, people think like 1 2. So 1 2 direction of fracture is not possible. What is the pitch between 1 and 2 bolts? It is okay, everybody will say 50. What is the gauge between 1 and 2 volts? The gauge between 1 and 2 volts is 0, right? So when the bottom value of this gauge is 0, this is plus infinite, right? So uh, when gauge is increasing, then I can say net width decreases, right? So from 1 to 2 there is only pitch is there, but gauge is no. When there is no gauge, then in such case this value will be plus infinite, na? So in such case the net width is keep on increasing. So a horizontal way of fracture is not possible. First of all, you should understand. So that means in such case the only possible way for me is I need to take only this vertical way. If I take only in this vertical way, there are three holes are there, as the three bolts are three holes are there. So coming to A net, how I can take this A net width is how much? 100 plus 100 plus 50 plus 50, 300 minus number of holes along this critical section. If I take this is 1 2, maybe let me show, if I say this is 1 2, this is 3 4 5 along 1 2 3 4 5 section. What is the net area, net width? Net width is 300 minus how many holes are there? 3 holes are there along 1 2 3 4 5. 1 2 3 4 5 minus what is the diameter of each and every hole? Diameter of each and every hole is 25 millimeter. 25. So if you take from second hole to third hole, is there any pitch? Is there? No pitch is there from second hole to third hole. Pitch is the distance that is measured between two adjacent bolts in the direction of load. In the direction of load, the pitch is 0 between 2 to third bolt, and between third to fourth bolt also, between third to fourth hole, the pitch is 0, right? So I can say that pitch square that we can avoid, so multiplied by thickness I can write. So this is the net width. Now what is this net width, brother? The net width will be definitely 300 minus 3 times of 25. It is 200. We can write it as 200. Directly we can write it as 225 millimeter, right? 225 millimeter. Dear Sudeep Gautam, it is not D for Detroit, it is B for Boston, because you are able to see this is 1 2 3 volts are here, and the load is not only applied here, the load is also acting in this direction. So in this way the crack can also happen in this way. You are thinking only the crack will happen in this way, which is not correct, as the load is also in this direction also. So from this left hand side direction also the cracks will originate definitely. Is that okay, dear Sudeep Gautam? The option is B for Boston is the correct option, not D for Detroit. Is that okay? Right. Dear Dharma Railway, steel structure classes are available in Unacademy channel. Yes, dear brother, steel structure. Yes, dear Arjun Yadav, I had completed even plate gutter also, brother. Especially in this Let's Crack GATE and ESE YouTube channel. Plate gutter is there in YouTube, and gantry gutter is there in gantry gutter, and beams are there in what I can say in Unacademy channel. So go and use that. Okay. Yes. Okay. Is that okay? Shall I move to next question? Coming to price, dear Dharma Railway, I can say like for single subject it is not available, but you can take, if you want to crack only for 1 month, you can use this 1 month course. You can take this one. If you are, especially if you are interested only to take 1 month course, then you will be provided access to that 1 month course. In 1 month you can work out that entire steel structures also. The cost is 4,500 for 1 month course. You will provide access to all the subjects, brother. Okay, after 10% discount. So not 4,500, brother, it is 4,950. Sorry, prices after 20 October, na? I should say like, yes, the price is 4,950. Right. You can use this price and you can get down to that. Is that okay, Dharma? Right? So go and take the subscription. It is available there. Okay. Okay, let me come down to the question. Okay. Right. Yes. So moving to the next question. I hope you are able to see the question, brother Dharma. or any other person, Sudeep Gautam, okay, Vandana Simran, Arjun Yadav, all brothers and sisters who are on the online. Okay, bending, compressive, and tensile stress respectively. The bending, compressive, and tensile stress respected are calculated. It is based on gross cross-sectional area, net cross-sectional area. In case of compressive stresses, if you take compression, the there there won't be, in case of bending compressive stresses, there won't be any gap between holes and fasteners. So in such case, need to consider it as the gross cross-sectional area. But whereas in case of tensile stresses, there will be gap between holes and fasteners. When there is a gap between holes and fasteners, then in such case we can call it as then we need to use it as net cross sectional area. So right now, for bending compressive stresses, if I want to work out a developing one, I need to use the gross cross sectional area. Whereas for bending tensile stresses, I need to use net cross sectional area. So I need to say like option B itself is correct, because for bending compressive stress, I need to use gross cross sectional area. Whereas bending tensile stress, I need to use net cross sectional area. The option is B for Boston is the correct option, right? So can I move to the next question? Is that okay, Sudeep Gautam? Yeah, moving to the next question. Right. I hope you are able to see the next question. If the yield stress of a structural member made of steel is Fi is something, this value is given, then which one of the following are correct? So what is the permissible tensile stress in axial tension? For axial tension, it is 0.6 times of Fi. Fi is 230, na? 230. And coming to this one, permissible bending stress in tension. Permissible bending stress in tension is 0.66 times of F5, which is 230. Permissible shear stress, how we can consider permissible shear stress? 0.4 times of F5. F5 is 230. So if you work out these answers, now you tell me, brother, if you work out these answers, you tell me. I just want to convey you, like, if it is 86, this answer is 138. This answer is 151.8. This is 92. So 92 is matching here with 92. So the correct option is C. E and B are not the correct options. I can say correct option is C for Catholic. This is the correct option. Is that okay? Dear Sudeep Gautam, right? Arjun Yadav, right? Dharma Railway, or any other person who are on the online, right? So can I move to the correct option is C. Can I move to the next question? Yeah. Right. So can you see here? I had forgot to given the options, but anyway, when two angle sections subjected to tensile force are connected to the same side of the gusset plate. This is gusset plate. This is a tension member. Two angle sections are connected to the same side of the gusset plate in this way. Just like that of a T section, or maybe some angle sections which are connected on the same side of the gusset plate. In this case, right, the effective area, what is the effective area? How to take the effective area? Effective area is nothing but net area, A net. So these are connected on the same side of the gusset plate. Maybe this way. Right, how you can work out the net area? A net is equal to A1 plus K times of A2. The value of K is here for this, when these are, and the two angles are connected on the same side of the gusset plate. The value of this K is 5A1 by 5A1 plus A2, where A1 is net cross-sectional area of connected legs, A2 cross-sectional area of cross-sectional area of outstand leg. This is how you can work. So this option will be there, and the option for K is 5A1 by 5A1 plus A2. Like that you need to answer. So I mean I just want to go to the next slide in which we will tackle about compression members. We had completed the clauses in working stress method for all tension members. Okay, we are moving to compression members. Is that okay? Right? So moving to compression members. So I hope you are able to see the next question, man. Right? This next question as per IS 800. So as per IS 800, I can say 1984 code. Thickness of the slab base. So what is the thickness of the slab base as per IS 800 1984 code is where A is the longer projection and B is the shorter projection. So A is longer projection and B is shorter projection, right? If W is the pressure, they are saying W is the pressure on the underside of the base and FB is the permissible bending stresses of slab bases. What is the permissible bending stresses of slab bases in case of old code of practice as per working stress method? The bending stresses of slab base for any type of steel, maybe mild steel or HVAC for any type of slab bases, it is 185 megapascal. This is allowable bending stress or permissible bending stress in slab base. Same thing. Now this is as per working stress method. Now what is the design bending stress in slab base as per limit state method? Design bending stress in slab base as per limit state method. As per limit state method. So as per limit state method is Fi by partial safety factor. And yield stress is governing the design. The partial safety factor is 1 point. This is the thing. And as here, if you come down, it is directly this one is the correct option, which is 3W. This is the option for thickness of the slab base as per old code of practice as per working stress method. So if you guys are expecting me to work out as per limit state of method, so as per limit state method we can write this one as, so if it is working stress method we can write it as this is 3W by permissible stress, which is FB into A square minus 1 by 4. I can write as 0.25 times of B square. This is how we can write, where A and B are long and short projections, right? Now this is as per working stress method. Now if I write the same thing as per limit state method, the option B is correct one. So as per limit state method, if I want to work as per limit state method, if I want to work out, so as per limit state method, if I say it is square root of 2.5 times of this W by permissible stress. What is the permissible stress? Fi by 1.1, or this 1.1 is called as gamma mu generally if you refer to code of into A square minus it is 0.3 times of B square. So this is the answer in case of limit state of method. This is the answer in case of working stress method. Okay. So some people had a doubt like, sir, what is this 1 by 4 here? This 1 by 4, which is 0.25. This 1 by 4 here it is nothing but Poisson's ratio for steel is taken as 1 by 4 in old code of practice. But in a new code of practice, that Poisson's ratio for steel is taken as 0.3. Let me write that as a note, the difference between old code and new code. In old code, mu for steel is 1 by 4, which is 0.25. In a new code, mu for steel, Poisson's ratio for steel, it is taken as 0.3. This is how we can take. Sir, it will be 0.5. B2, I guess. B2, I guess. Dear Omkar Vasagadkar. Dear Omkar Gasadkar, dear, I had clearly mentioned it is not about the guess. This is clearly it was given in code of practice. The correct option is B for Boston, no doubt at all. Here this is 1 by 4. Now 1 by 4 is how much, brother? You are able to see. This is my a square minus 1 by 4 times of b square. That 1 by 4 itself is nothing but that is the Poisson's ratio for steel, right? So here the Poisson's ratio in case of limit state method is 0.3, whereas Poisson's ratio in working stress method is 0.25. That is the only difference. Okay, here FB is 185. Here the permissible or design stress, design bending stress in slab basis F5 by 1.1. That is the difference between these two. Omkar, Vasa, Gadekar. Okay, the correct option is B for Boston is the correct option, no doubt. But just I am discussing what is the difference between this formula in working stress method and in limit state method. That discussion I am doing. The correct option is B, no doubt at all. As per working stress method, what is the difference between the same formula for this working stress method and for limit state method? I am just discussing these two. Okay, right. So 0.5 it is not so, brother. If you refer to the steel, if you refer to the fundamentals of strength of materials, your SM teacher might have already teach you the Poisson's ratio for steel will range between 0.25 to 0.3. For concrete, it will be between 0.15 to 0.2. The ranges for different materials, the Poisson's ratio was already given to you in your strength of materials module, dear Omkar Vasa Gadekar. Is that okay? Can I move to the next question? Is that okay? Right? Right. Moving to the next question, brother. Yeah. The correct option is B for Boston, no doubt at all, as per working stress method. But to pick any limit state answer, there is no such limit state answer is matching here. So, and moreover, they just mentioned IS 800. They didn't mention IS 1984 or 2007. So to avoid such thing, the options were directly given only in working stress method. Now, so I can pick only option B. Okay, yeah. So coming to the next question, I hope you are able to see the next question, brother. So can you see this next question? Right. So if 20 millimeter rivets are used in lacing bars, if the nominal diameter of rivets are 20 millimeter, brother, then what is the minimum width of lacing bars? So what is the minimum width of lacing bar that I need to use? Is there any clause is there as per old code or new code? Yes, even in old code and new code, the minimum width of lacing bar is equal to 3 times of nominal diameter of the rivet. Phi. Phi stands for nominal diameter of rivet. This is the minimum width of lacing bar I need to use. So in such case, 3 times of 20 millimeter, the answer is 60 millimeter. Na? So directly you can pick option B itself is the correct answer. Some people will have a doubt like, sir, if I don't use this minimum width of lacing bar, if I take this is the width of the lacing bar, if I keep a big hole here, if I don't provide sufficient width called as B, maybe 3 times of D. If I provide a width less than 3 times of B, in such case, by during the time of this riveting process itself, there is a fracture will happen in this element because we don't provide minimum sufficient edge distance. That is the major problem. So minimum width I need to provide is for the lacing element, for the lacing width, the width of the lacing bar is 3 times of the diameter, 3 times of nominal diameter of the rivet. Is that okay? So the correct option is B for Boston, right? Is that okay, Omkar Vasa Gadekar? Is that okay, bye? Sudeep Gautam, right? Dharma, yeah. Deepak Raj, how many total lectures in this module? Dear Deepak Raj, totally in this module, I will work out 300 questions for steel structures. So I cannot say about the number of hours. So till now I am able to work out 89 questions, like 200 plus more questions are yet to come in the complete steel structures. So you can understand, I cannot say about the duration of hours, but definitely I will work out 300 plus questions in steel structures, so that I can even discuss the clauses and I can even work out the problems, either maybe theory or maybe clauses. Is that okay, dear Deepak Raj? Deepak Raj, is that okay? Right? Can I move to the next question? Is that okay? Next question or maybe next specification, anything. Of course, we are connecting those specifications with the help of questions, right? Yeah. So moving to the next specification question. Yeah. I hope you are able to see this one. In case of lacing bars, where we will use this lacing system general, in case of built up columns, in case of built up columns, to tie uh, two or more rolled sections to act together, we provide this lacing system. We provide lacing system. I hope that is the fundamental thing that you know, right? In lacing bars in steel column, lacing bars, if I take, this is a steel rolled section, this is another steel rolled section. These two rolled sections are kept together with the help of lacing system. I hope, let me show. This is the lacing system which is connecting these two rolled sections together in this, right? Now when in this case I can say whether these lacing elements will carry bending moment. See, the lacing elements will carry shear, transverse shear, as per IS 800, 2007, or maybe 1984, old code of practice also, anything. As per IS 800, 2007, lacing elements will resist a transverse shear force of 2.5 percentage of total factored axial load on column. This is as per new code of practice. As per old code of practice, if you take, in old code of practice, it is based on limits. This is as per limit state method. As per working stress method, the answer is one and same, but instead of total factored load, in working stress method, we don't use factored loads. We will take the load that is actually coming on the structure, which is people call it as service load. So in such case, we can take lacing elements will be designed, will resist a transverse, needs to resist a transverse shear force of 2.5 percentage of service load acting on column, or indirectly it is nothing but column load, and it is the nature of force is shear force. People think like the option is C, but in option C, whether it was mentioned like transverse shear or shear force, is there anything was mentioned here? Omkar Vasagatekar, is there anything was mentioned like is it shear force? The nature of force was not mentioned in option C. Like they just mentioned 2.5 percentage of column load. Okay, whether it is shear force, whether it is bending moment, whether it is torsional moment, nothing was mentioned. Will you pick C? No. We have some sense like what is the nature of force should be mentioned. But if you refer to option B, they clearly mention it is a shear force. Okay, that is coming into picture due to 2.5 percentage of column load. Yes, that magnitude of the transverse shear force is 2.5 percentage of column load that is developing. Yes, that option B itself is correct. Option C you cannot pick, because the nature of force was clearly mentioned in option B, but the nature of force that was there is not mentioned in option C. So option C is wrong, brother. Okay, option B itself is correct. Is that okay? Omkar Vasagadekar, is that okay? Deepak Raj, is that okay? Right? Yes. Can I move to the next slide? Can I move to next slide? Yeah. So moving to the next slide. I hope you are able to see next question. The channels, yeah. The channels are angles in the compression cords. The channels are angles in the compression cords of a steel truss girder bridges are turned outward. Okay. In steel girder bridge or anything, in case of bridges or any stuff, especially the top cord in compression cords. Compression cords means in case of compression members, indirectly. In compression members, the channels or angles are kept away, turned away from the CG of the section. If this is a channel section, from certain distance, from this one, another channel section was kept. That is, the two channel sections were kept away from the CG of this built up section. Why these are kept away from the CG of the built up section? Because in case of compression members, to increase FCD, design compressive stress is increased when lambda is decreased. When this lambda is decreased, when lambda is decreased, indirectly when R minimum is increased, that means minimum radius of gyration is increased. So that means when this R minimum is increased, R minimum is square root of I minimum by A. So where R minimum is increased, when minimum moment of inertia of the cross section will increase. The minimum moment of inertia of the cross section will increase when it is thrown, and the area is thrown away from the when the area is thrown away from the CG of the cross section. This is the CG of the cross section, CG of built up section. From this CG, the area is thrown away. So when the area is thrown away from this built up section, obviously minimum moment of inertia will get increased. So minimum radius of gyration will get increased. So I can say option D for Detroit is the correct option. So because in order to increase what will get increased, brother, here when the cross section area is thrown away from the centroidal axis, in such case radius of gyration will get increased, right? So the correct option is D. When radius of gyration R minimum is increasing, then the lambda slenderness ratio is LE by R minimum. This will decrease. When a lambda is decreased, then obviously I can say FCD, design compressive stress of column, FCD increases. When FCD, design compressive stress of column increases, the load carrying capacity of the column, increases. This is how we can do, brother. So the correct option is D for Detroit. Can I move to the next question, brother Omkar Vasa Gadekar? Can I move to the next slide? Okay. Next question, I mean. Right. Moving to the next question. Right. I hope you are able to see the next question, brother. Which one of the following pairs is correctly matched? Right. So which of the following pairs in truss members are axial members, like axial forces will come, but no bending will come in case of truss, because in case of truss joints are ideally hinged or pinned and the loads are acting exactly at the joints, the members will not bend, right? So this is a wrong option. In truss you can take like axial forces is the correct option if needs to become. In beam generally bending is possible, flexure or bending, but here they are saying the primary itself is twisting, torsion. No, in beam torsion will develop, but the major torsion can get developed when the CG of the loading is not coinciding with the CG of the plane of the beam. In such case that in that beam is subjected to twisting. But in beam, the major primary internal force is bending moment, right? Bending moment. In case of column, yes, in case of column, the primary failure is either by buckling or axial crushing. Yes, these two are things. This is correct one, it seems like. In shaft, if you take a shaft, I hope if you take a shaft in this way, what is the nature of stress? That the shaft will keep on rotate about this axis. In such case, it will be subjected to torsional moment, right? So it is not shortening. I can say in shaft, I can say twisting or torsional moment is the possible stuff. So directly I can say like the correct option. This is also wrong. The correct option is only option C itself seems like correct. Like for column, the mode of failure is coming into picture because of buckling action. Is that okay? Is that okay? The option is C. Is that okay, brother? Is that okay? The correct option is C. Because whereas the remaining options were given as wrong options, right? In truss, the axial forces are dominant or axial deformation is possible, right? In case of beam, flexural deformation or bend. Flexural deformation is possible because of bending moment. In column, right, buckling is possible, right? In case of shaft, twisting is possible because it is keep on getting rotated about the major axis. Is that okay? The major axis, in sense, it is rotated about the axis of the shaft, right? So can I move to the next question? Yes, moving to the next question. I hope you are able to see. An electric pole of 5-meter height is fixed into foundation. You can take an electric pole. An electric pole is fixed into foundation. So it is fixed. It carries a wire at the top. It carries a wire. Maybe it carries a wire. It carries a wire at the top. This is the wire at the top. Maybe I can, this is why, this is why. It carries a wire at the top and it is free move sideways. When it is free to move sideways, like when it is free to move sideways. So when it is free to move sideways, I can say, but it is directly attached with this wire. This is the wire and this is wire. When there is wire is there, in such case, if I want to make this point to move, if I want to make this point to move in this direction, this wire will resist that horizontal deformation. If this point needs to be moved to this left hand side, this wire will resist that this left hand side deformation. That means it is, there is no, at this bottom end it is fixed. You can read like at this top end it is not completely free, I can say. I can say at the top, in the direction of the wire, in the direction of wire, the pole is hinged. The pole is hinged at the wire end. As the pole is hinged at the wire end, I hope you can say when it is hinged at the wire end. In such case, what is this effective length? This effective length is almost just like that of 0.8 times of L. 0.8 times of L. So in such case, the effective length is 0.8 times of L. So 0.8 times of actual length is 5 meter. So in such case, it is 4 meter. This is how we can work out. The correct option is B for Boston. We can pick which is 4 meter. Is that okay? Right. So can I move to the next slide? I hope you already know when both ends are fixed. When both ends are fixed, in such case, the theoretical effective length, L effective theoretical, it is 0.5 times of L. Effective practical effective length, it is theoretical, it is for practical effective 0.65 times of L. When both ends, one end is fixed, another end is hinged, right? It is fixed, another end is hinged. Then in such case, here there are two effective lengths are there. The effective length, theoretical effective length is L by root 2. Practical effective length is 0.8 times of L. This is practical effective length. And one end is fixed, another end is hinged. In such case, L effective is 2 times of L. I hope you know these effective lengths values directly in columns, especially from your strength of materials module. Same stuff here also we can use, right? Can I move to the next slide, right? So moving to the next slide here, for a compression member having the same effective length, okay, for a compression member having the same effective length about any cross-sectional axis, the most preferred section from the point of view strength. For a compression member, if you take the design compressive strength of a column, it is FCD, design compressive stress multiplied by gross cross-sectional area, or effective area in case of compression member is gross cross-sectional area. So to increase, what is for which element this FCD, design compressive stress, is more? design compressive stress. This FCD is increased when lambda is decreased. In which case the lambda is decreased. When lambda is decreased, R minimum is increased. When R minimum is increased, I can say minimum moment of inertia will also increase. In which case the moment of inertia minimum is increased, right? So first type is box section. I hope you can say a box section in sense. Generally for metros, you might have seen a box section in this way, right? Because of this box section, generally about this x-axis and about this y-y axis. Maybe this is z-z axis, this is maybe y-y axis. For example, about z-z axis also more area is thrown away from this z-z axis. About y-y axis also more area is thrown away from this y-y axis. So I can say about z-z axis and about y-y axis, I can say moment of inertia is high. I is increased about ZZ and YY axis. So more area is thrown away from this centroidal axis of ZZ and YY. So in case of this box section, R minimum is increased. Yes, this is the correct option here, I can take. But if you come down to I section, if you take an I section, if you just take only single I section, generally moment of inertia about ZZ is more, but moment of inertia about YY is less. But here in case of a box section, moment of inertia about ZZ and about YY are equally increased in case of box section. In case of circular section, I mean to circular section means this is how, right? So area is not thrown away from this neutral centroidal axis. It is a solid circular section. When it is a hollow circular section like this, then it is preferable. Area is thrown away from the neutral axis in such case. But here in this case, area is not thrown away. Not thrown away from neutral axis. Here in this case, area is thrown. Let me write down. Area is thrown away from neutral axis. A single angle section, when you take a single angle section, so it is not that much preferable, right? So in single angle section, they are not saying if you take about this axis, okay, but there is a chance like this may be the this may be the axis about which moment of inertia will be the minimum, right? So this is also much more prone to buckle. So the thing which will not buckle out of these four sections of same cross section area is the box section. So directly I can say box section itself is correct. In the option C, if it is a hollow circular section, then I can go for even a box section or hollow circular section. Both are one and same, right? So here I can only pick option A, which is box section is the only preferable option. Is that okay? This is a circular section, a solid circular section. Option C. So option C is not correct. Only option A itself is correct. Shall I move to the next slide, brother? Omkar, Vasudekar, Deepak Raj, Sudeep Gautam, or maybe Vandana Simran or Dharma Railway or any other person who are on the online, right? Shall I move to the next question? So please like our videos, share our videos, subscribe to our channel, brother. Please share our videos to your friends also, right? Coming to the next question, the slenderness ratio of lacing bar shall not exceed. Thus, what is the maximum slenderness ratio of lacing bar, brother? You take here, the slenderness ratio of lacing bar shall not exceed lambda of lacing bar. Lambda of lacing bar should not exceed how much, brother? 145. If lambda of lacing bar is exceeding 145, then lacing bar may buckle. Lacing bar will fail in buckling mode, right? So if you refer to the code of practice, old code of practice or new code of practice, the limiting slenderness ratio of lacing bar shall not exceed 145. The option is directly C is the option we can pick, brother, right? Shall I move to the next question? Moving to the next question. Which one among the following is correct ratio of effective length to actual length of a discontinuous angle strut? If you take a discontinuous angle strut, maybe if whenever these are all discontinuous angle struts are there, let us suppose this is gusset plates are there, you can think all these are all discontinuous angle struts. When you take a discontinuous angle strut, okay, with the welded thing, so I hope you maybe I can say this end is welded here, this end is welded. When I can say when single angle is when a single discontinuous angle strut is welded, in such case the effective length is 0.85 times of L. So let me write the condition directly from the code of practice if you refer. So for single angle discontinuous struts, okay, when it is connected by one bolt or rivet, in such case the effective length is equal to the distance between the centers of end fastening, distance between center of a fasteners I can say, right? So in this case indirectly L effective is equal to 1 times of L. When the single angle discontinuous strut is connected to the gusset plate with the help of more than two or more rivets or bolts or welding, two or more rivets or welding. In case of two or more rivets or welding, I can say effective length is equal to 0.85 times of 0.85 times of distance between center of fastening. So in such case 0.85 times of distance between load points. So this is more welds are in case of welding. So directly you can pick option B itself is the correct option. Is that okay, dear Omkar Vasudegar? Vasugadekar. So can I move to the next slide? Next question, brother Omkar. Right. So moving to the next question. Moving to the next question, I hope you are able to see this next question. In gusseted base, when the end of the column is machined, let me take a gusseted base for example. This is a column. This is a column. This column is resting on a gusseted base. This is the gusset base, which is having this gusset plate is also connected. This is how the gusseted base with gusset plate is there. Right. Why we are using this gusseted base rather than slab base? So why we are using this gusseted base? If we had used this gusseted base with gusset plate, I can say definitely like the overhangs will get reduced. Okay. And one more thing, when I apply with the help of an axial load P, how the load is transferred to this base plate. This is base plate. When the ends of the column is machined for complete bearing. When the ends of the column is machined for complete bearing means when the ends of the column are directly resting on the slab base. When the ends of column are resting on slab base. The ends of the column are directly resting on slab base. In such case, directly 50% of the load is transferred to the slab base by bearing and 50% through fastening, right? So 50% of load is transferred by bearing and 50% of the load, the percentage of load is transferred by fastening, I can say. So I can say directly, this is directly clause from IS 800 2007, especially in case of IS 800 2007 or IS 800 1984, in case of slab basis. Directly I can pick option C itself is the correct option. So shall I move to the next question, brother? So can I move to the next question? Some people had a doubt like, sir, for example, if the gazetted base is in gas if in the gazetted base, if the end of column is not end of the column is not machined properly, if end of the column is not machined properly, then end of the column is not machined properly, then directly 100% of column load is transferred by fastening. This may be first class and this may be second class, but you can see it is not machined properly, in sense it is not in touch, it is not resting on the slab base properly. There is no proper contact between the column and the slab base. In such case, total 100% of load is transferred to the base plate by fasteners directly. Okay, can I move to the next slide, brother? Is that okay? Moving to the next slide. I hope you are able to see this question. Question number 98. Right. In this question number 98, so I hope, which one of the following values represents the maximum slenderness ratio for any connection member which normally act as a tie? Tie means tension member. Tension member in a roof truss, but can be subject to possible reversal of stresses from the action of wind or seismic force. From the action of wind or seismic force, its value is directly, I can say, from this is the maximum slenderness ratio for any connection member which acts as a tie, which acts as a tension member in a roof truss, which is subject to possible reversal of stresses from the action of wind or seismic force. From the action of wind or seismic force, its value can be taken as, when it is a tie member, its value can be taken as 350. Right. Directly 350. So this option we had already discussed. Okay, right. Moving to the next question. So next, coming to the next question, stipulations in designing a laced column. A single lacing system on opposite planes shall preferably the same direction, so that one is the shadow of the other. Yes, correct. This is correct. Lacing bar shall be of a flat section. I cannot say that one lacing bar shall always be a flat section. Lacing bar can be a channel section or maybe an angle section also. So this is false. Should be, they mentioned a terminology called should be. It can be a flat section, it can be a channel section, it can be an angle section. So second option is not correct. Slenderness ratio of lacing bar for compression shall not exceed 180. No, it is not 180, it is 145. So this is also wrong. And coming to laced members are to be provided with tie plates at the ends. If we had tied two rolled members or to more than two rolled members with the help of this lacing, in such case definitely I need to use at the ends, I need to use definitely some batten plates, or these are also called as tie plates. Certain tie plates are used, one at the top and definitely one at the bottom, definitely should be used. Laser compression members are to be provided with tie plates at the ends. Yes, at the ends definitely they need to be provided with tie plates, and these tie plates are nothing but called as batten plates. Yes, end batten plates are to be provided. Yes, it is correct. So I can say option 1 and option 4 are correct now. So directly I can say option D. option D itself is correct. So for today, the time is almost like 2 hours. So I need to end this session. So we will tackle the remaining questions in your next or upcoming class. Yeah. Now coming to this subscription pitch, I mean, coming to the subscription price, if you want to get 12 months course in Unacademy Plus platform for Plus course, for 12 month subscription, the cost for ESE is 27,225 after 10% discount. I can recommend this 12 months course to the students who are in final year. If you are a student who are in third year, or maybe I can say third year or maybe second year, I can recommend this 24-month subscription. The cost for 24-month subscription after 10% discount is 39,600, this much. So for any of the course, if you want to follow, if you want to join either 1 month subscription course to 24-month subscription, to get 10% discount, you are bound to use this code VT10. When you are able to use this code VT10, directly 10% discount will directly come to you on all the course in Unacademy Plus, brother. On all the course in Unacademy Plus, right? And if you want to follow me, you can use the link which is given here. After you download the Unacademy learning app, use this link. When you press this link, you are able to follow. When you are able to follow me, then already the free content that I had done for you for free of cost, you are able to access that one. The future notifications of free lectures will be notified to you. And at the end of each and every free class, we will provide a PDF notes that you are able to get for free of cost. These are the 3 advantages when you are able to follow, right? And I just want to convey, every day my class is happening in this Let's Crack GATE and ESE Civil YouTube channel. Every day my class is happening by 11 a.m. So please don't forget to come down to my class. And I am recommending even Kamalakar Pandey sir class also, who is going to teach non-structured subjects. Every day his class is by 11 a.m. in the same channel. I can recommend even Kamalakar sir Pandey's class also. Right? And I just want to convey, you are getting all this content for free of cost, right? So please inform the same thing to your brothers and sisters, to your friends who are in civil engineering. Please inform the same thing about this channel to your friends, so that they will also come down to this channel and they will also use this free content at least. And there is so much of paid courses are also there in Unacademy learning app. If you are a serious aspirant of any of the competitive examination, then I can definitely recommend you guys to take the paid course subscription, brother. So finally I can convey you, like, you please subscribe to this Let's Crack GATE and ESE YouTube channel, GATE and ESE Civil YouTube channel. Then don't forget to press the bell icon. When you press the bell icon, the future coming videos in this channel will be notified to you. Then you will not be seen a single video free in this channel. One thing. So other faculty are also going to teach in the same channel. For other faculty also, you will get the lectures notification you will get when you hit this bell icon, brother. So I recommend you guys to raise a thumbs up. Please give the thumbs up. Please like our videos, share our videos, subscribe to our channel. And for you guys, I already started a Telegram group, especially for you guys. If you want to resolve your doubts, you come down to my Telegram, my personalized Telegram group, which is Unacademy_Venkata Tilak. If you, how you can come down to this channel, you use the link which is given below. If you are able to use the link which is given below, which is Unacademy_Civil_Engineer_Tilak, if you press this link, directly you guys will be redirected to my channel. Then you can, whatever may be the doubt that you have, you can directly post your doubt directly in that Telegram group. I will respond to your doubts definitely, right? Please inform the same thing to your friends. So please subscribe to our Telegram group also, and please subscribe to our Let's Crack GATE and ESE Civil YouTube channel also. Okay, and thank you very much. Thank you. End of the session for today. Okay, right.